Ooh. All right, so welcome to this month's meeting. I honestly have been too busy to really pay attention to what you guys were going to teach. So I know Courtney wanted to do something GIS and bringing it into CAD, right? And then when you're done, Andy wants to talk to us about uh, terrain model point cloud data. I can't remember. So instead of trying to guess, I'm just going to hand it over to Courtney. And you are muted, Courtney.
Thanks for having me today. Today I was thinking about discussing some somewhat antiquated methods of bringing in GIS data and consuming it in CAD and then giving that back to GIS. So a little bit about me. I am a civil CAD designer over at Pate Dawson Engineers. I hold professional certifications in Civil 3D, and I'm a GISP, remote pilot for UAS. I have a handful of degrees, and I'm highly involved in the CAD and GIS community in supporting women in geography and GIS, ERISA Texas, Texas GIS Day, our CAD user group, and many more. So if y'all would like to join us next Tuesday, we're having a Mappy Hour where we're going to do kind of a lean coffee discussion where the attendees are going to make the path of the discussion. So if you attend, hopefully we'll get into some conversations about what we saw at the Esri User Conference this past week. And I live in Kyle with my surveyor fiance, Jeremy, and my two beautiful miniature dachshunds, Bonnie and Clyde. As you can see, they're dressed as Bonnie and Clyde. So data. Where do we get it, and from who, and at what quality level? So today, I'm only going to touch on a few data sources, but I thought I'd share at the federal level for our, I guess, mainly civil projects. I utilize the National Map Viewer a lot, the NHD, the U.S. Fish and Wildlife, National Wetland Inventory, the USDA Geospatial Data Gateway if I don't have any access to a GIS platform that can give me the source data in a specific projection. That's a really good tool. Of course, Fema, TNRIS, TxDOT, and definitely go to your county level and your council of governments and appraisal districts for your parcels. All right, so I sped up all these videos so we could go through some things quickly. This is the USGS National Map Viewer where I get my NHD data. It's worth going ahead and getting the NHD Plus, which is higher resolution, topo-based national hydrography data set for water. This is the Geospatial Data Gateway where you enter in your state and county, and notice they have a lot of different data sets, and they are pulling from the authoritative data such as USGS for a lot of these. There's your hydrography data set, but it's not NHD Plus. So be looking for what you'd like there, and you can, for example, get your Surgo data for soils, but it only comes in an Esri file geodatabase because it's such a large data set. So you can do things like your geographic names and get your Esri shapefile and your local projection. The FEMA Map Service Center is where you go to get all your firm maps as well as your up-to-date GIS data for it. You can search what area you'd like. Today, I'm focusing on the Circuit of Americas area in the city of Austin. You'll go to Show All Products, Effective Products, expand your National Flood Hazard Layer. 45.3 is Travis County, and go ahead and get that downloaded. We're going over to the TNRIS website and looking for their data hub. for our statewide data. It's in order from your latest data that they have available. You can also search geographically. So here we're looking for our Central Texas LiDAR. We're not exactly sure what we need, but we know it's about this area. So I go ahead and download the hypsography, which is contours. Then I'm going to definitely want City of Austin data. You can just quickly do a Google search and it takes you to those pages. Their open data portal has a lot of information. So becoming familiar with the way that they describe things, such as waterway setbacks for creek buffer lines, is really important. All these buffer lines are different widths depending on what type of stream they're designated as. Got that download started, and I usually dissolve that in GIS so that it's a continuous buffer all the way around without segmented areas per each stream. Critical environmental features are also incredibly important for our civil projects. Data management. I am a huge proponent of data management. It is incredibly important. But before we jump in there, let's look at a couple of other data sources. Our property profile for the city of Austin. If you don't know about it, well, now you know. You go there for all of your permits that are out, right-of-ways, other conditions you may not think about going and get data sets for. So it's really important to go there. If you want your local flood data, go to Austin Flood Pro. For other counties and other cities, there will be other data sources, and you'll probably be working directly with the municipality. You can search by a place, or I got off of the property profile that we're in the Dry Creek East watershed. And then you download per what type of hydrology that you need in your files. So here is the data management portion. So I bring in my waterway setbacks, and I always make a text README file where I put in some of the metadata that I get off of the website, what day I downloaded it, and by whom, me, and I put my email address in there for the company because I want all of my coworkers to know when did I get that data, and that way if it's updated, they know that my data that I downloaded is out of date. And then hopefully your company has a good file management system where, for example, I can contact my GIS team and get it on the folders available for everybody to use now that I've made a recent download. They have it set up to where it's a geo export and a unique ID. I go ahead and rename that and then clean up my folder structure so that I have a clear path for that. On the TNRIS site, I know they periodically update the way that they describe the metadata. So I think it's really important to go back to that site and copy a lot of this metadata information on the side. And then if you haven't downloaded it, there is a link on that page for you to download the index of what number the quarter quads are so that you can overlap it with your site, either in CAD or GIS, and identify those specific quarter quads. There is a small citation available, so if you are using this in your production maps, you'll want to go ahead and get that citation listed there. Data assimilation. It may be time consuming, but this has saved me year after year. As you can see, this is a screenshot from some of my 2016 work, which I have gone back and made sure everything still seems relatively correct. I can follow my workflow after so many years, almost 5 years. So you can see all of my data sources and my source data, how I rename them to be Clear Creek lines. There's my README file. There's the original zip file in case I feel like the integrity of the data has been taken away. In my working data folder, I have projected them to my local projection that I'm utilizing, as well as taken the individual stream critical water quality zones, which is those waterway setbacks. And I also did a dissolve in here as well. So data preparation in ArcMap. If you don't have ArcMap, you won't always have this opportunity, but we're looking at these parcels and boy, they look skewed, don't they? So I'm making sure that my map has the projection that I'm looking for, which is Texas Central and US survey feet. So, oh, okay, everything looks a little bit better for the Circuit of the Americas region. My flood hazard data, I always do by unique values in the flood zone and the zone sub entity, and then I rename my label so that it's clear. It's a 100-year flood zone in zone A. Then I go ahead and query each one individually and export them so that I can bring in each layer clearly in CAD. Because if I just bring in this whole data set, I have all this overlapping polygons, and it makes it challenging, more challenging for me, at least in CAD, to distinguish these layers individually. So I do that export, but oh no, I didn't project it. Well, I could have chose the data frames projection for that export. And then some data you just need to project. So I go over and I do project under data management, and then I input my data sets and my output for my working data folder. So I know things that I have modified from source data. I turn on my LiDAR availability and I try to identify, oh, well, I think the Circuit of America region is right around in here. So I take a little screenshot of what I think the strat map quarter quads are. Well, after that, I went ahead and did add data up here in the large black plus sign in the yellow diamond near the scale is the add data. And I added my base map of aerial imagery so that I could see the Circuit of Americas clearly. And there is 6 overlapping quarter quads that are here. So that is where I would go whenever I create my surface. So let's talk about importing into Civil 3D to create your base map. So I always make sure that my drawing settings have the coordinate system I'm looking for. Then I bring in my data. Oh, but that's a weird input coordinate system, isn't it? You can right click on your projection file and open it in Notepad to identify the projection if you don't have something like ArcGIS to utilize that information for. So I've determined that this is WGS 84 in lat long and have imported my planometric data, which is essentially your building and road outlines. This is going to help delineate those features of the Circuit of Americas for the parking lots, for example. Here you can clearly see the parking lots brought in. Then I'm going to make sure that I have my parcels. So the planometrics I had already scaled, and then I can also edit the drawing layer as I'm in this wizard, bring it in per the defined window, so I don't have to bring the whole county's worth of parcels in. So this is all through the map import wizard. Well, you can see clearly that my scale is off. So working with my surveyors, I isolate this layer and scale about 0.000 and utilize the proper fraction of the scale factor. So 10,000, excuse me, 100,000 over my 99988 that I got from my surveyors. Then I make sure it's on a good color that's kind of in the background. And now I think my base map is complete. And you can see there in my layers that I identify all of my Fema hazard layers. This is a really cool tool called Map Trim. It is not Xtrim. It is Map Trim so that it retains the GIS data that we just imported. As we said, create object data, and that's all of the attributes from GIS. You can see here when I brought in the wastewater lines that I had applied my styles as well. You can also bring in your manholes as blocks too. I think that these things are really helpful as you import the data rather than trying to translate that afterwards. So what would we do if we wanted to give the GIS data back to our GIS team, but modified? So let's say I did some edits to these wastewater lines and put them in the right place according to my project. Well, we can use the map export command, give it a proper name that would be clearly identified. And then I usually isolate that layer and do select manually. On the second tab, we can give it back the object data for wastewater main. And I usually add the layer and the DWG name as well, so that they know where that data came from. If it was truly in 3D, we could have created a 3D shapefile for them and they could have made a 3D model potentially from it. How do we create a surface from GIS contours? We don't always have the luxury of having access to a DEM. So I think it's important to know this process. It is one of many of creating a surface from GIS contours. But this particular process I have found keeps the integrity of the data. So I utilize map import and then I scale it. And at that point, you can do a map trim if you'd like. I tend to wait towards the end because it seems like they always want more area for hydrologic assessments. Then I will attach the DWG in my map workspace, execute a query for completing the GIS geometry to our new geometries. Then I create my surface and clean it up. Let's see that in QuickTime. So I am bringing in that base file that I just created so that I can see my GIS data overlaid with my CAD for the Circuit of Americas. Make sure I'm actually going to bring in all of the contours I need. So I connected to my folder, brought that in, turning off the polygons and the multi-patch. I know they're a little light here, but I would go to transformations, enable transformations from 0 to 0, and then put in my decimal scale factor in here in order to bring my surface drawing back to grid. So I've identified that I'm going to need at least 2 more tiles for my topo surface to cover the region that I need. So I took a quick screenshot of that, came into my DWG, made sure my coordinate system was correct. Now I am exporting my folder for my strat map information that is based on 2017 LiDAR. And then I identify which quarter quads to bring in. Well, I need another quad. So identifying them, if you hover, the number will come up in the bottom left-hand corner that you see there. It popped up. So I just add that quad information that I downloaded to my README file so that I make sure that I'm consistent with my data management. Then I start to bring in each area of contours that I need. Make sure you create object data, but also I would need to know the input coordinate system. So I right-clicked on my projection file to open it in Notepad. Oh, but what unit is it? Is it US survey feet or is it in meters? Well, it is in fact in units of meters. So I make sure that that UTM 83-14, I copy it to make it easy for me to copy and paste as I continue. I always do import closed polygons because if there's like a hill or something, I just want to make sure that it imports polygons as closed polylines correctly. And quickly bring in my other 4 quarter quads. And I didn't do a define window for this because I wanted to make sure I brought in all the data. As you can see here, it does have an elevation. So if you're working in grid, you don't have to go any further. You can create your surface from here. But most of us in the civil world are working with our surveyors that have a scale factor. So as you can see here, my base map and my source data aren't lining up. So my next step is I do a series step in my archive folder so that I know what's going on. This one's my scaled. So as I scale it, this actually affects the Z's in my geometry. So I'm no longer 530, I'm 530.036 or whatever. So I'm creating a new DWG. I'm ensuring that my coordinate system is set correctly. To me, that's a really important part of our steps for things that have to do with GIS data and our preliminary data sets. I'm calling this one 3D scaled. I'm closing what I called 2D scaled. They used to not come in with any geometry. So I'm just a creature of habit in my naming conventions. You're going to want to open your map W space and then go to your Map Explorer tab and attach a drawing. Here I created an alias to go to my drive where this drawing was located, and I attached the 2D scaled drawing. Then I have to create a query where I do my location by all and I draw it, and then I'm going to want to edit the property alterations and make sure that I'm connecting to my expression of elevation equals elevation from my GIS data, and make sure you say add each time to push that. Did a quick check, alter properties, execute query. Bam, all of my contours have drawn, and notice my elevation in my geometry and my attributes are the same now. I'm opening my 2D scaled one so that you can clearly see that the elevations were altered after I had scaled. So now I have a DWG where everything seems to be great and it's scaled in my horizontal location. Now I'm creating a surface, and then I'm going to add my contours under definition. This takes a little bit of time to render. These are fairly large data sets. CAD tends to choke a little bit the larger the data set. That is something I'm really hoping is fixed in the future, as well as different processes affect CAD differently. This happens to be one that it just takes a little bit of time to generate your tin for. Now that I've generated it, I can zoom in and see that my tin is in the right location with my base map. And I'm also looking for areas where my tin and my contours are not overlapping. So I'm identifying areas where there's like lows and highs to make sure I'm not triangulating incorrectly across them, so that I can clean up those areas before I do my final cropping. You can easily do that by edit surface and swap edges. Here I am creating essentially my metadata for my surface. When I create a surface from GIS data, I make sure to give the information and forward, right? Pay it forward. You know where you got all that information. Now share it back with your team members who may end up doing edits that you're unaware of in the future, or they may have to tell the client, where did your source data come from? Now they easily have that information at their fingertips. I did a save, and now I noticed, man, I really got some excess terrain. I'm going to say extract from surface, create a cropped surface. And I created my new drawing with my proper template. I gave it a name and a style and brought that into my new DWG. Now, because it is essentially recreating that tin, it does take a few moments. I'm coming over, it's triangulating and zoom extents to make sure that it looks good. It does. I am going to save it in my hierarchy of folders to use this surface as my data reference. But I did all that work to create that description in the other file. So make sure you copy that back over to the file that you're actually going to be using for your data reference prior to creating the data reference, so that that description carries through. I made sure that it's on whatever layer your company uses for surfaces. Typically it's 0, but sometimes they choose different ones. And I want to go back and say that this is the USGS quality level 2, which is important to note. So I made sure that all of my data matched the quality level of the 2-foot Gis contours that were available to me in GIS. So, any questions? I know that was quick. No questions? Well, if y'all think about them, you can stick them in the chat. We can get to them at the end. Or if y'all know how to get a hold of the CAD user group, I'm sure they can be filtered down to me. I appreciate y'all for having me join you. And there's a lot more that I wanted to share, especially about upcoming tools that are going to be used more in the future, and how to connect to different data and maybe bring in labels as well to make our massive labeling projects in CAD a little easier on us. So I think that might be fun for future discussions.
Yeah, that would be great. Maybe have you come back in a couple months and talk about all that.
Excellent.
Have you played with any of the new, how ArcView is supposed to be able to tie in with CAD in 2021?
I have only touched it once, and that was just last week. And I'm not liking it great at the moment, but I think that that has to do with my just lack of experience with it. One of the things that I keep asking is, how do I consume that data but scale it from grid to surface coordinates, right? How do I apply my scale factor for every project differently? I'm not getting great answers for that, and I'm hoping that that is either a function that's easily available to me, or that I can, access that maybe in the future if they offer it. So
Okay.
And yeah, Tom said that he likes the idea of scaling the contours and then applying the elevations based on the map data. Yeah, that definitely has been my key workflow. It takes longer than some other workflows, but I feel like it holds the integrity of the data a lot better.
Yeah, one of the things we do is use the 3D Analyst extension in ArcMap and go ahead and apply the elevations so that they come in at elevation already. But then if you scale them, obviously that breaks that thing, but just reapplying those elevations based on the map, you could have either the grid location or the scaled location, depending on what you need.
Yeah, I know a lot of people just like do a little circle scale on the side and then like move their whole surface, which is acceptable in some cases, but when you're doing engineering, you want the best possible data, right? And it seems like this method really holds the integrity of the published contours better, in my opinion.
I also like the way that you set up your data to say, here's where I got the data, here's the date and all that, because that's one of the things that we're trying to get properly documented on sheets. And it gives us a way to find that source.
Yeah, accountability and responsibility tends to be really lost in translation as we do projects and as the years go by, right? We might remember for a few months, but from 2016, I wouldn't have remembered exactly when I downloaded that data set. So it can be really valuable to document as you go. It takes a little bit of extra time, but boy, you're going to appreciate yourself later, right? Say, future Courtney appreciates past Courtney for taking care of that.
All right. So if there are no other questions for Courtney for right now, thank you, Courtney, for that. Hopefully we'll see more of you in the future. And then let's kick over to Andy so he can present his little thing. If he's still there.
Thank you.
A little thing. I don't know if the little thing. No, it's this is going to be a little bit related, and it's going to be a lot of stuff that I think a lot of civil users aren't initiated to. So it's going to be kind of a high level. I call it a quick lecture, but it's going to be really fast. And then we'll get into kind of a practical use. I'll jump back into CAD and I'll show you exactly what the hell I do to get what I'm talking about. And I think this is going to become more and more commonplace in the next, I don't know, 5, 6, 7 years. I think it's probably pretty cutting edge now. So I'm going to give you some terms. We're going to talk about some things. We're going to do it really fast. You can go back and watch the video later if you want. But what I'm going to talk about is something that I think is really awesome. It's called entwine. And if you haven't heard that term yet, all that means is it's a way to take a bunch of point cloud data and mash it into one massive cloud-centric geospatial data set that sits on Amazon or somebody else's server, not yours. And then you make a request and just get the data that you want. So if you've heard of GDAL before in the geospatial world, that's the Geospatial Data Abstraction Library. I think the Autodesk developers actually use this inside of MAP because it's open source, although open source gets a little weird with them. But there's another thing that's out now, and it's a sibling, or it's of GDAL, which is more new, which is called PDAL, which is the Point Data Abstraction Library. And that's how point cloud data are handled on an Open Geospatial Consortium level. So we'll kind of go through this fast. I'm doing this remote through another computer, so it's a bit of a weird thing. So entwine, its point file, if you want to think of it as a giant, massive mamma jamma point cloud file, it's called an EPT, or an entwine point tile. And it's actually a relatively interesting structure. I won't go through the math, but you can take a bunch of LAZ files, i.e. all of the tiles, and you can mash them into one giant point cloud to rule them all. And this has already been done for us. The US Geological Survey has done this for all of their flights. Be nice for the folks that are in Austin that if TenRes would do something similar. They have not, but I've been kind of harassing them about that. All of this data sits on Amazon, USGS public exposure. So you don't have to pay for any of this. I know if some of y'all have messed with AWS or Amazon Web Services before, sometimes you get lost into something called requester pays. This is a public bucket. Bucket's kind of a storage system on AWS, but a public bucket, if you do it the right way and the way that I'm about to show you, you won't have to pay a dime. So it's available. You just have to know how to get it. I saw Craig was on the call, and I think he's out of luck, but I think some others that are on the call that aren't in Texas. This is currently the footprint that AWS has for the entwine point cloud data. So if you're in one of those footprints, you can get a point cloud of any kind of small polygonal area or a large polygonal area that you want. This changes daily as they're uploading and encoding, but this is all of the US Geological Survey's effort. Notice there's as when I pulled this one back in May, there were 29 trillion points in about 1,600 resources. You can think of resources as entwine point clouds in this case. This changes as new data comes online, gets QC'd, gets published. Doesn't mean that there isn't terrain data where you're at. It's just it's not on the USGS server. So you need to keep that in mind as well. So there might be an area where, if you're up in Montana or North Dakota, that it's just not available. Ohio does have contiguous coverage from a state level, but they just haven't pushed it and published it to the US Geological Survey. So this is what I'm going to be showing you is going to be a USGS centric approach, but it doesn't mean that there won't be others in the near future. The USGS does have data gaps. Remember the Georgetown acquisition from Tenres? Tenres has not submitted that to the USGS for QC. So we do have good point cloud data in Austin, mostly. That's queryable, but there are areas where you're not going to get in-twine coverage. You'll have to go fishing somewhere else to get the point cloud data if you need it. You have to download the raw LAZs. I hate figuring out which tile I'm in and downloading the terrain that I need. I hate it. I'm trying to figure out a way to get around that, right? And that's kind of what this workflow is going to do. So what the hell is in-twine? In-twine is kind of well, I think of it as a format, and then if you want to request data from it, you build something that's a JSON file that is a in-twine pipeline request. I know this is really technical, but I want you just to kind of see what we're doing here, because it's kind of a logical workflow. So you say what bounds of data that you need. You tell it what file it needs to be requesting. So that is the resource. This is on Amazon West. It's the USGS. All this I'm programmatically figuring out, but we'll figure out what's happening. And then I read the point cloud. So I say, give me the limits, filter out everything that's a classification that's not 7. So you kind of need to know how LAS point clouds are built. You know, there's classifications, ground, there's all that kind of stuff. And then we smurf the surface, and there's a whole bunch of crap going on here. But things are kind of working in sequence. So we read the data, we filter by a range, meaning don't give me, this is exclamation point says do not give me as opposed to give me. So do not give me classification 7, then wipe everything that's remaining to classification 0, reproject it to, I think this is like universal transmercator. We could pick a projection, smurf the surface, that's to simplify it. SMRF means something, it's an acronym, but a lot of people call that smurfing. And then you groundify the surface. We're not going to do this, but this is just kind of an overview of someone else doing the same thing. This is something I did. So I fed it a polygonal boundary and said, just give me the point cloud of this bridge. I don't care what tiles it's in. I said, just give me the ground. So I'm saying, here's the boundary, read the data set, crop it to the boundary, give me everything that's classification between 2 and 17, and then remove everything that's between 3 and 8. And what I'm doing there is I'm trying to get the ground and the bridge deck, because the bridge deck sits on 17 and ground sits on classification 2. So what that returns to me is about 260,000 points out of that 3.7 trillion points in Texas, and says, all right, here's your point cloud. And that's cute. That doesn't help me for CAD though, right, Andy? I don't want point cloud, I want a DEM. An in-twine point cloud flow can actually give you a DEM. And that's what I'm doing here. So this is a HEC-RAS model where I don't have the underlying ground terrain. So I've written a short little Python script, which I'm not expecting y'all to do, but it's a short little Python script that figures out the spatial boundary of the RAS model, goes and looks at the in-twine point cloud, pulls that point cloud for just the ground data, reverses it into a digital elevation model and says, okay, in the projection that you're in with the vertical units that you want, here is the ground data for the specific polygonal request. And that's kind of what we're going to show. I'll get out of this. We'll get into real CAD here in a second. Let me jump out of this. Sorry, I got too much crap at the top. That's going to drive me nuts. Come on. That, thank you. Awesome. Okay, so here I am in just AutoCAD. I have done nothing. This is the default Civil 3D template. I've set the projection to Central Texas US survey feet. I brought in an aerial and I drew a polygon saying, I'm gonna need the point cloud and the ground data for that. That's what I want. So kind of what Courtney did, I'm doing similarly, right? I set up the drawing, I put it on the right projection. This is not super complicated stuff. We've all done it. TX83-CF, so that's Central US survey foot. That's what's set up. I brought the aerial in and I said, I just drew a little polygon. I closed it and I did a map export. And that map export gave me a shapefile, which I called area of interest. So I'll just show you how I did it. If you don't know how to do this, and I created this area of interest too, but I'm going to override it just so we can kind of do it. So polygon, select manually, go to the options, treat closed polygons as polyline, and then select manually. and then say okay, and now I've got that as a shapefile. So it's just got one polygon in it, and that's kind of important. You don't really want to request a bunch. I do have a way to handle it, but in this case, we just want one. That shapefile is on Central Texas US Survey foot. All the point cloud data is not. So that's where it's going to get really nasty really fast, but I'll show you how long it takes. I don't expect you to know how to do this, but I'll kind of walk it through as we run. So I'm in Jupyter Notebook running Python with a bunch of libraries for those that are initiated. For those that aren't, don't be scared. So I'm just going to run it as I step through. So I'm going to load a shapefile, which is that CAD Austin, and then the area of interest 2, which is an area polygon, and it's in 2277. That's Central Texas US Survey feet in European Petroleum Science Group projections. And then I gave it a couple of directories to dump the data. Okay. Make sure I run it as I go. So then I needed to determine the entwined data that's in the request. Remember, there's 1,522 different data sets. Some are in different states. They're all over the map. So what I'm doing here is I'm reading a file that's on GitHub and is updated daily by the US Geological Survey. And that just is a boundary. It's a GeoJSON file. It's a boundary of all those 1,560 something. It just does a spatial intersect and figures out which one I'm in. And then it, from that, returns the URL that is the right data set. My dog's getting grumpy in the background, but he's gonna be fine. Okay, so I could overwrite it manually if I need to, but this is typically what the link to the EPT file looks like. So it's HTTPS, and then it's on S3, which is Amazon's data storage, and it's USGS-LiDAR public, and this would be Louisiana Sabine River LiDAR A3. I don't need to know what that is. I really just need the program to programmatically figure out which one I'm in. So I'm going to skip this step. It's commented out. So this is how you get the point cloud data. So I'm just going to run it. It should take it. So I've asked for that area around the bridge that we drew in CAD, right? Because it's reading that shapefile. It looked at those 3 million or those 30 trillion points, and it took about 4.5 seconds to extract just the point cloud for the spatial limit that I want. So imagine if you've got a site that's a few acres, it shouldn't take long. I mean, obviously the bigger you get, I think a square mile takes about 3 to 3.5 minutes to make that request. So this point cloud, this entwine pipeline just asked for the point cloud. It just said, give me the point cloud and write it as an LAS file, right? And it did. So it saved off to the side. So now I'm going to do something different where I said, okay, read the same limits and then crop it by the boundary that I'm asking. Give me everything that's ground classification 2 to 17, remove 3 to 8. So give me ground and bridge. And then write out, this is where it gets really interesting, write out a digital elevation model, a DEM, ground. And give me no data is this. And what's really important here is what resolution do you want? So a lot of us have been dealing with the US Geological Survey or 10Res's DEMs, and we're locked into a resolution, 1 meter, 5 meter, 3 meter, 10 meter, whatever they publish. This method actually allows me to produce my own digital elevation models at whatever resolution I want to produce from the point cloud itself. In this case, I'm saying give it to me in 0.3 meters, which is about a foot. So I'm actually getting a better data surface, but I'm also getting a heavier data surface than what the pre-can data comes as. You could use the pre-can data, but I'm not. Now, when you pull that data, there's going to be gaps. So I'm using this to fill the gaps. It took about 4 seconds to create the digital elevation model. I'm going to fill in the gaps. Don't worry about that. Just know that it does. And then I'm going to use something that's called Rio X-Array, which is a wonderful, wonderful tool. And it's going to convert all the vertical data from meters to feet. And it's going to do it really fast. Yeah, it's done. So there's just a plot of the data that we requested. And I'm just going to write everything out. And just trust me, I have all this data. It's working. Let me see if I can get out of this little screen share crap that's going to drive me nuts. Got it. Awesome. Okay, so we're back in CAD. What data have we pulled over? Okay, this is we're kind of getting to the end of the practical application. So let's take a look. I think I'm good on time. Yep. Let's see what we have. I think that's sitting on Dropbox. So let me pull that up. I just want you to see the data that is not what I want. Let's do it this way. Cool. I think I put it under Austin CAD. Okay, so it created 2 files because I asked it to. It created a created terrain.tiff. That's a geotiff. So it's got the geospatial metadata in it, and it created a raw point cloud LAS file. And you're like, well, that raw point cloud file is kind of cute, but what can I do with it? Well, this is what I do. I go to a website that, if you don't know, is wonderful. It's plas.io. It's a point cloud viewer. You don't want to put big files in here. You only want to put small stuff. It's a bit of a pain. So I take it and drag it in. And you're like, well, it's there, right? Did I see it? I want the density up. I'm gonna do this one more time. All right, so I'll drag it in. Trust me, it's there. You have to fight it with a little bit. So it got about 40,000 points in the point cloud. Told me what version it is. This is the point cloud raw, wasn't converted, so it's still in meters. Particle size, I'm gonna fat up. And I'm gonna change the blending scheme somewhere. It's gonna take it. I knew I was gonna fight something. There we go. So that's the point cloud as requested. And it's just the spatial limits that I asked for. And that's the beauty of the Entwine, right? Because the Entwine will be able to look with it uses video game technology to create an octree if you're curious. And then that octree allows you to sample just the points that you want. Effectively, how do I find data in a very, very large data set fast? You're like, how's that video game technology? Well, if you're in Call of Duty and you're rendering trillions of polygons of objects, you need a way to look up those vertices really, really fast. So that's what Entwine is doing with point cloud data. It's doing the same thing. So that shows you what's going on. Again, I asked for the bridge. I didn't mow it out. And you are picking up cars, but you can mow all that stuff out if you make your Entwine request appropriately. Just like say, give me just ground, right? But in this case, I wanted to make a point. So this is just kind of a tool that I use just to see what I have, right? Did I get what I thought I get? Are the trees in there? Have the trees been removed? You know, all that stuff is available. So now that I have that, I've got this created terrain. That created terrain file, since I did a bunch of gymnastics with my code, is actually a Central Texas, maybe US survey foot, and in vertical is in feet. So what I'm trying to show you is somebody comes in my office or your office and says, I need this surface here. How do I get that? This is how I would do it. And this is how I would do it really fast. I wouldn't go figure out tiles. I wouldn't figure out any of that crap. I would just go to the raw point cloud with some code and kind of scrape it down. Yeah, I know that's not real doable by all of us yet, but I think as time starts moving to the right, you're going to see it as more and more common of a workflow. So how do I get that surface? Well, I can go in surface and I can say, under prospector, surface, create surface from DEM. And I'll bring in that created terrain file. Remember the verticals in feet because I converted it with Rio X-Array, and we'll see what happens. Okay, that's a terrible style, but like I said, I just use the default template. So I'm going to go to surface properties. We'll change that to 1 and 5 design, and it's going to be a problem. And I think most of us have seen this problem before. Let's see if I can show it to you, obviously. Yeah. So if you know where I'm at, and some of you do and some of you don't, this concrete is at the toe of the slope of that channel. That contour, last contour line, it's showing the bottom of the channel over here, right? That surface is off. This is a known and documented problem inside of Civil 3D. What is happening? So remember I was talking about GDAL, Geospatial Data Abstraction Library? I suspect, although I haven't had it horribly confirmed, I suspect that the programmers, and most of them are out of Shanghai, China, that write Civil 3D have been heavily using the GDAL library to figure out how to make data ingestions and extrapolations. When it comes to DEMs, digital elevation models, the metadata of this geotiff says that it is in feet. So the programmers in Shanghai said, all right, it's in feet, bring it in feet. And us in our world, us Americans, we go, wait a minute, there's 2 feet. There's the international foot and there's the US survey foot. And they are different. And they are like 2 parts per million different. So, you know, if I'm measuring something on the ground, who cares if it's in US feet and international feet? But when I'm scaling stuff or inserting stuff from an origin of a state plane coordinate system, which is the origin is millions of feet away from where I'm at, those 2 parts per million add up. And that sucks. But this is what I'm about to show you doesn't have anything to do with the Entwine. This is just how to clean a DEM that you get from a third party that's coming in and it's screwing up. This is how I do it. So I create a circle somewhere in the middle of the site, like of the surface, right? I kind of want roughly the centroid. You don't need to be perfect. You just need to pick a point. And I query it and I figure out what its XY locations are of that point. And then I open up Excel and get real ghetto. So let's see if I can get this to work. It's probably not going to work. I'll just explain what I'm doing as I'm doing it. So I'm gonna copy that C value, I'm sorry, the X value, the center X value, and the center Y value. And that's going to tell me the state plane XY location. Okay. I'm going to multiply. So that's in international feet. I want it in US survey feet. So in order to convert, I have to multiply that times 2 parts per million. So you just need to know that is the conversion number. So you do equals this times that. And you go, I'm gonna static it out. So that's where it should be, and that's where it should be. So now what I really need to know is how much do I need to move it? So I'm just going to subtract where it should be with where it is supposed to be. And it's going to tell me delta X is 6.2 or 6.2 feet. Delta Y is 20.21. So I'm going to take a line, center, and I'm going to say at 6.2 comma 20.21. And I'm going to pick this guy up and I'm going to move it from center to endpoint. So I did kind of a naughty, dirty thing, right? I picked up and moved to DEM. That's not a good thing to do. But if you look at the aerial, now you're like, well, the bridge doesn't line up. That's because of the way the LiDAR scan hit it and what the angle of attack was when they flew it. That's okay. That's not the end of the world. But you need to eyeball things. And what's gonna be really subtle to a lot of us is when you have a road, it's obvious. When you're out in the middle of BFE and you've got, some forest like that, you'll bring it in and you'll think you're right, that you're in the right location. And CAD is going to lie to you. If you bring in a DEM as a surface, and a lot of people want to murder me when I bring in a DEM as a surface because it's gigantic, it's really heavy. Just know that AutoCAD has a known flaw that when you bring in a DEM to create a surface and the units are in feet, it just assumes that it's in international feet and not US survey feet. And if you are trying to get it in, and why aren't we? We all are now trying to get it into a state plane coordinate system, it will come in the wrong spot. Usually it's a little bit down and to the left. And the error for which it needs to move is a function of where you are on the planet, right? In that projection coordinate zone. So let's see if we've got everything. That's a Civil 3D surface. It is. I'm going to add some spot elevations to make sure I'm not just completely crazy, that I've got it in the right surface. Yeah, it's 528. It's 511. That seems reasonable for where I'm at. That is in feet, so we're good. That is a Civil 3D surface. It's really heavy. If you look at its triangulation, we should have a triangulation about every foot because that's what we asked to produce the DEM at. And let me see if I can make that happen fast. Yeah, triangles. I don't recommend you turning on the triangles on a TEM because it's usually really, especially on a big surface, it's really slow. This is not a big surface. This is a relatively small surface. So you can look and there's your triangulation. So that should be 0.3 meters, should roughly be a foot. Let's see, quite close. Yeah, it's 0.85 feet. So that's how I get a DEM. I create my own DEMs from entwined point cloud data, and I do it from an ingested front end polygon. And that is all I'm going to talk about today. I've got other things. I could talk about cloud optimized terrain till the cows come home. A few things, if you're curious and want to dig a little deeper, the US Geological Survey does have a DEM service that is a web, I can't remember what it's a WCS. I can't remember what the C stands for. Coverage, I think, web coverage service. You can request 1 meter DEMs programmatically without downloading tiles from the GS. Wouldn't it be nice if Tenres did the same thing? They haven't yet. And you can scrape terrain that way, but you just get digital elevation models, but you could do that as well. And that's where I'm starting to lean towards for really big watersheds to kind of scrape data down that way. The other things that I've tried is scraping DEM data from Tenres, but that I think y'all have seen that before. With that, I'll take questions. I know that's like drinking from a fire hydrant with me, but at least it kind of shows you a preview of the world to come, that there are going to be giant cloud optimized, organized data sets that we don't really need to worry about tiling anymore. We just need to figure out a workflow and a pipeline to scrape those data down as they come online. So I'll stop sharing. I know, right? Oh my God, I don't understand what you just said. That's okay. It'll sink in.
Yeah, that was a lot.
But y'all can clearly see why my antiquated workflow is my tried and true daily method, because whenever I would, for example, just consume the DEM straight from Tinris, I would also have that same issue that Andy pointed out. And I did not choose to pick up and move the data. I decided to try to hold the integrity of the quality level as much as possible by ingesting the contours that were presented and published, by them. So yeah, I'm really excited to utilize some of those workflows in the future.
Yeah, I think you can get higher resolution terrain. I think that's really the only rub, right? Is that sometimes you try to go find the federal data sets and they're, oh my God, they're in universal transmercator and they're in meters and they're, 3 foot or 3 meter resolution. What the hell do I do? Your natural instinct is, I just want the point cloud. Let's just go get the point cloud and I'll get the surface that I need. If you can't process point clouds yourself to create surfaces, and a lot of us can, you're kind of stuck. What I'm trying to show you is that the PDAL stuff it's just a bigger point cloud, right? It's the same workflow. If you go grab the LAS tiles from some municipality or LAZ tiles and run it through and reduce that point down to ground and bring it in, you can do that. And then a lot of people go, oh, that surface is ugly, right? It's got a bunch of little pot marks and egg crates and it looks like crap. Then the next step is you just got to clean it, right? You run a smoothing algorithm and understand what it's doing when it is doing a smoothing algorithm. And you're going, yeah, but that's not the raw data that came off the plane. Here's what I'm going to tell you. The GS, the Tenres, all the vendors that do that, they do the same damn thing, right? They scrub and filter out the noise out of their DEM contours and ground surfaces. They are altering the data as it comes in. They do have certain QC criteria about how accurate that surface has to be, both horizontally and vertically. So they do have some tolerance, and they know that we don't want noisy contours, right? That we don't desire that. So what I'm giving you is effectively the equivalent of you going hiring a drone and scanning the world. And I'm just telling you that the US Geological Survey has put all that data that they've acquired publicly on Amazon for about half of the United States. So you need really detailed surface in an area where GS has acquired it, and you can't use the USGS DEM or it's just not good enough. All right, let's just go back to their point cloud data. In the olden days, and I say olden days is like 2 years ago, I would just go download the LAS file and I would do the same thing. But what Entwine has done is it's mashed it into one data system. And now I just have to be clever about how to polygonally request what I'm looking for and go pull that. So there's options, right? There's a lot of options. You can use contours to create surfaces. You can use DEMs to create surfaces. You can use point clouds to create surfaces. You can go have a surveyor spend, a week out in the field hitting spots to create surfaces. I think the answer is always it's an amalgamation of all of them, right? Because you're not going to go survey an entire watershed. You're crazy if you do that. So go get the data that you need and go use it. What do I want to show in CAD? Man, I'll tell you what Courtney's doing. We kind of had some similar angst that I needed to create a proposed drainage area map for a very large watershed. And I would go pull the DEM and I'd bring the DEM in and everybody would just lose their mind. So what we started doing is we would export the DEM contours as a shapefile. And then I would create a surface from those contours and just use that mainly as a labeling surface. It wasn't anything I was doing time of concentrations against or any of that kind of stuff, but it was a CAD centric label surface. And I'm just trying to lighten the load, right? Because in CAD, all we need is the contours. We need contour labels, we need flow arrows, and we need drainage areas, parcels to be able to sit on top of those. I don't need super high resolution terrain for the drainage area, at least for the publication of the sheet. Now for the calculation of the sheet, I might, but that might be done somewhere else. But that's definitely not going to be something I'm going to be using as a data reference in my proposed macro drainage area map. You're crazy if you do that. But I think a lot of us do. And then people get grumpy because, servers pushing that data reference surface around. Is that a lot? Yes. Questions? I'll take them if you got them, but I know it's like drinking from a fire hydrant. So it'll sink in 3 days and then you'll go, oh yeah, I saw that.
When I rewatched your video for the third or fourth time.
Justin, you usually have something to say. So have you seen that before? Have you messed with that?
No, but I want to so hard.
Are you a Python centric guy?
I do a lot with Python.
Okay, I can send you the script if you want to play with it.
I'd love to.
Okay, just email me and I'll send it to you. It's like, I think it's like 100 lines of code. Like it's stupid basic.
That's awesome.
Yeah, it's a sexy little thing that just to
It
write
is, man. I know, this is going to go on YouTube later and there's women present, but I had a semi when I started seeing you do that.
Oh my God.
I was
Well,
just like, yes, this is awesome.
That'll be edited out.
No, it
but,
won't.
Nobody
No.
has time for editing.
To me, that was the beauty of it. So, if I had a brand new site and I just needed really good terrain, I could do that. The other thing is you can also use the same data set to get not just the ground, you can get the ground plus the trees, which they call the DSM, like the digital surface model. So now I might not know where the trees, might not know how many trees I have, but I know where the tall canopies are, and I know where I have tree coverage. So I can create that surface and bring it into Civil 3D. And now you've got two surfaces, right? You got the ground and you've got the one with the top of trees, which is more useful than you think. And specifically when you start talking to we could talk for hours on this, but I've got ways that I can effectively make a guess on how many trees are on a site before a survey even goes out and say, I might be off by 10, 15, 20%, but I didn't even go set foot on a site. Like I just used the point cloud data that's coming from USGS Entwine to be able to give them an estimate as to where trees are and how many there are. And that's some cool stuff too. So now that plas.io, you can use that for any point cloud anybody ever gives you. And that's just a good way to kind of look at stuff as you get it. And you don't download anything. It's all web enabled. You just take the LAS file and you just drag it in. I like that. I think that's a cool thing, but don't bring in massive mega, quarter quads. I think that's what Courtney was talking about. That's the way the TenRes organize them. So everybody on this call, if you've got a pipeline to TenRes, which is the Texas group that does all the data, go harass them and tell them, stop giving us a downloadable zip of 16 quarter quads. Just organize your data in cloud optimized geotiffs and Entwine. So I can just make a programmatic query for what I want. And and AWS would just programmatically return. And you're going, wait a minute, TenRes doesn't use AWS. Yes, they do. All of their data is coming from AWS, all of it, every last ounce of it, as is the GS, as is the US Geological Survey. It's all coming from, some giant, massive data system store.
Mm-hmm.
So that's it. I'll shut up. We're at 1 o'clock. So Andy's done and I'll hang around as long as anybody wants to hang around.
So just in case
Alright.
anybody was wondering, I was using Autodesk Civil 3D 2019, which is also why some of my workflows are a little antiquated because I don't have access to some of the cool new tools that are accessible through like Arc Connector and other Dynamo scripts, etc. So if somebody is also on lower versions, they may want to utilize some of these static map imports.
All right. Well, thank you guys, Courtney, Andy. It was really informative. I'm probably gonna have to rewatch this video a couple of times. I know for sure Andy's stuff. I'm gonna stop the recording, but if you guys want to hang out and answer any other questions.
Yeah, I'm looking forward to using those scripts in the future. Thanks, Andy.